Good day and welcome to my tutorial on Super Mario Brothers the Mario Brothers versus the right angle triangles. Now, Super Mario Brothers, it just happens to be one of my favorite games of all times, and I just want to use it as an excuse to help you all understand right angle triangles in terms of trigonometry. So today, using some some snapshots from the Super Mario Brothers game, we're going to be reviewing sine, tan, cosine, and of course, Pythagoras Theorem. So on the screen here, right, you'll see a little snapshot from the Super Mario Brothers game. In case you're not familiar with the characters, this over here is a piranha plant. Right, that's the actual name of the enemy. Over here, the name of this enemy here is Rex. And of course, everybody knows Mario. Right? So, moving down. Now, this is probably what a gamer sees. But below here is what a mathematician may see. So, what you notice here on the screen, right? If I connect if I put lines in between the enemies and Mario, I was able to form a right angle triangle. So you can clearly see the dimensions here, but I'm going to put some letters here so we can communicate a little more, a little clearer. I'm going to call Mario, I could just call Mario's M, the piranha plant is P, and Rex will be R. So I haven't decided what we will be finding in this particular question. So let me decide that now. Let's say that we wanted to find the length of this side here from P all the way to R. Now you will notice that an angle is involved and it is a right angle triangle. So I'm going to zoom into some formulas here that you all should be very, very familiar with already, right? So over here we have sine, tan, and cosine, and over here is our Pythagoras Theorem. Now, whenever there's a right angle triangle and there is an angle involved, right? You notice there's a 34 degrees here. Whenever there's an angle involved, usually it's sine, tan, or cosine we have to use. Pythagoras theorem is actually used to find a missing side provided that you have the lengths of two other sides. Now, this is something I just found out the other day, right? When it comes to a right angle triangle, I believe everybody knows what the hypotenuse is. The hypotenuse is the longest side of a triangle, of a right angle triangle, but it's always opposite the right angle. So the hypotenuse actually has a special name, the hypotenuse. Did you know that the other two sides are called legs? So a right angle triangle has a hypotenuse and two legs. I'm just going to call one leg A and one called leg B. This here is Pythagoras theorem, and it's equal to hypotenuse squared is equal to leg A squared plus the length of leg B squared. But later on, as we bounce up a question involving Pythagoras theorem, I'll talk about it in a little more detail. So let's go back to this question over here. In this question, we want to find the length from R all the way to P. So let's label this triangle in terms of sides, like the opposite, the adjacent, and the hypotenuse. Pretend that you are standing in the 34 degrees. The side opposite the right angle, you notice there's a right angle here by Mario. The side opposite the right angle is always your hypotenuse. So we have just identified the hypotenuse. Now, if you're standing by the 34 degrees, well then, just follow the cursor here. This side would be the opposite. So I'm going to put an O for the opposite. So if this side is the hypotenuse and this side is the opposite, then the remaining side is the adjacent, A for adjacent. Whenever I have a right angle triangle, one of the first things I always do is label the hypotenuse, the opposite, and the adjacent. I always identify the hypotenuse first. You know why? Because he is always the easiest to identify. He will always be opposite the right angle. Then I pretend I'm standing in the angle and look for the opposite side, the side opposite that angle. To me, he is always the second easiest to figure out. So after the hypotenuse, I go to the opposite. And there will only be one more side remaining in the triangle. So obviously he is going to be the adjacent. So I usually identify the adjacent third. So in this question, what are we trying to find? Well, it seems to me we are trying to find the hypotenuse, because that's where the question mark is. We have not been given any information on the opposite, nor do they want us to find it. So I think the opposite is going to be pretty useless in today's question. And they have given us the length of the adjacent side, 28 meters. So I'm thinking he's going to be very useful. Once you have information on a side, it's probably a good idea to keep him around. So it seems to me, I'm just going to write in the corner here, we want to find the hypotenuse, and they gave us the length of the adjacent side. So we have to go to our sine, tan, and cosine formulas and see which one has hypotenuse and adjacent in it. Remember, we don't care about the opposite. So let's zoom in here. Which is the one we want? Which one has hypotenuse and adjacent? Well, I think that would be cosine. That would be this guy here. You notice he has hypotenuse and adjacent. So a lot of students have problems figuring out like which one, like if we have, what are we saying? I'm just mixing up myself there. We are trying to find the hypotenuse. So whatever we are trying to find, we have to block it out. Now we have just identified we are trying we will be using the cosine formula itself. So if we are trying to find the hypotenuse, what I want you to do is pretend that you just blocked out the hypotenuse. If you block out the hypotenuse, then you are left with adjacent, and this line here is a divide, adjacent divided by cos theta. So the rule is whatever you are trying to find, you block it. And whatever you block, you write it and put an equal sign right after. And on the other side, write what you are left with. If we block the hypotenuse, we are left with adjacent divided by cos A. So we write that in, adjacent divided by cos A. By the way, this A here, right? Well, this A here stands for the angle. This A on top is the adjacent side. So cos A is cos of the angle that we are standing in. Remember, the angle that we are standing in is 34. So let's finish this question off. What's the length of the adjacent side? 28 meters divided by cos. And how much is the angle we are standing in? 34. Let's work that out, and that will be the end of the question. So 28 divided by cos 34, and we get 33.77 meters, and that's the length of our hypotenuse. That's the length from P to R. Okay guys, so that was our first question, right? Let's move on to the next question here. So I've used the same clip, but this time I've changed the information. Let's say, now let me put in the letters here first. We have Mario, we have the piranha plant, and we have Rex. Let's say we want to find this angle here. So I'm going to put a question mark. So we are trying to find angle R. Now, we are trying to find an angle. So we either have to use sine, tan, or cosine. Let's start identifying the sides. First of all, this is the angle in consideration. So whenever we have to figure out who is the opposite, we have to pretend we are standing over here. But anyway, let's identify the hypotenuse. The side opposite the hypotenuse, the side opposite the right angle is the hypotenuse. So here's definitely the hypotenuse. I always identify him first. Now, if I am standing in by this angle, that's angle R, then the 29 meters will be the opposite. So if I know the hypotenuse and the opposite, then this side is the adjacent. Keep in mind, we are trying to find angle R. We have been given information on the opposite, so that's good. And we have been given information, the 44 meters, on the hypotenuse. We have been given no information on the adjacent side. So guess who is going to be useless? Well, the useless item here is who? The adjacent. So let's go to our formula and look for someone with opposite and hypotenuse. So let's zoom in here a little bit. I know it's kind of difficult to see, right? Which one has O and H? I think this would be sine. So remember, in this case, we are not trying to find the opposite. We have the opposite. We are not trying to find the hypotenuse. We have the hypotenuse. We are actually trying to find the angle. So whenever you are trying to find the angle, you block the whole sine A or tan A or cosine A. But in this case, we are using the sine. So we are going to block the whole of the sine. Whatever you block, you write it. So if we're trying to find angle, well, in this case here, A is the angle and the name of the angle is R. So I guess it's appropriate. We could throw away the A and put R. Now, whatever we block, I'm going to scrape it. I'm just going to cross it out there. When we block the sine R, we are left with opposite, and this is a divide sign here. Opposite divided by hypotenuse. So it's opposite divided by hypotenuse. Let's plug in the values here. What's the length of the opposite side? The opposite side is 29 and the hypotenuse is 44. Let's divide this. 29 divided by 44. This will give us, well, I'm going to go to 3 decimal places there. 0.659. That's a pretty easy call. So that means sine R, the angle we want to find, remember it's angle R, is equal to 0.659. But a lot of students stop here by mistake. Anytime you're trying to find an angle, in this case here's angle R, you want R alone on one side. So which means you need to throw across the sine. So when you throw across the sine, you will get sine inverse 0.659. Anytime we're trying to find an angle, you will be forced to use either the sine inverse, cos inverse, or tan inverse. You will see it in orange hovering above the buttons. Now, sine and sine inverse, that is sine with the -1, are not the same. They're opposites. So don't make the mistake and press sine 0.659. Please don't do that. You want sine inverse. So you press second function, sine 0.659. And when we do that, we will get 41.22 degrees. So we have the angle R now, and that's the end of the question. Let's move down now. It's the same here. Now this one here is going to give me an excuse to use Pythagoras Theorem. All right. So let me just expand the page here so you can see everything. We want to find the length of this side here. Now you notice they gave you the length of two sides, the 55 and the 33, and they want you to find a missing side. no angle is involved. By angles being involved, I mean angles other than the right angle triangle. Pythagoras theorem and these guys only work with right angle triangles. So when I'm talking about an angle being involved, I'm talking about either this angle or this angle. And those angles are not involved. So we will not be using sine, tan, or cosine. Instead, it's Mr. Pythagoras theorem. So according to Pythagoras theorem, hypotenuse squared is equal to leg A squared plus leg B squared. Remember, the legs are the two sides which are not the hypotenuse. So let's just identify the hypotenuse first of all. The side opposite the right angle is the hypotenuse. So he is the hypotenuse. The two other sides are just legs. Just call any one leg A and the other one leg B. So to find the hypotenuse squared, leg A is what? 55 squared, and leg B is how much? 33 squared. So let's work this out in our calculator here. 55 squared plus 33 squared, and I'm getting a really huge number. So hypotenuse squared is equal to 4114. But this is not the end of the question. We want hypotenuse alone. We don't care for the squared. So we throw across the squared, and the opposite of a squared is square root. So let's square root that. Square root 4114. And it seems that we get our hypotenuse to be 64.14. All right. So I just want to show, well, no, whenever you find any hypotenuse, that's pretty easy. I just want to go back up to this question here, right? I just want to change it up. Is there an eraser? Yeah, there's an eraser here. Right. I want to do over this question, but I'm going to make it into a different question where I'm forced to use Pythagoras theorem. So let's give me a few seconds to erase everything here. It's a little clunky. All right. Let's say in this particular question, right? Let me change the values. If here was 29 and you're seeing the 29, and we change here to 59 meters, and we wanted to find this side here. Once again, you have two sides and you want to find a missing side, and this angle is not involved and this angle is not involved. So it's Pythagoras theorem. The side opposite the right angle is your hypotenuse, and the other two sides, when we're using Pythagoras theorem, you just call one leg A and the other one leg B. So let's write back Pythagoras theorem. Hypotenuse squared is equal to leg A squared plus what? Leg B squared. Let's put in the values. Hypotenuse squared. 59 squared is equal to leg A squared. That's the 29 squared. And we don't know leg B. Let's work out 59 squared and 29 squared on our calculator. So we have 59 squared. Yes, sir. 59 squared. And that will give us, let's see, 3481. Let's work out 29 squared now. 29 squared. And that gives us 841 plus LB squared. So you want to solve for LB. So in this case here now, we have to throw across the positive 841. That will give us minus 841. And this will be equal to LB squared. Leg B squared. So what we're going to do now, we're going to minus these two and then throw across the square root sign. So I'm running out of space here. I'm going to scroll down a little bit, right? Let's work it out. 3,481 minus 841 will give us 2640, and this is equal to LB squared. Throw across the squared, and now we get a square root. So LB is going to be what now? The square root of 2640. And we will get what? 551.38 meters. Now it's really, now that's the final answer for this length here, leg B. Now it's really important to know, especially if you're doing CXC, right? Now I just use the official names, hypotenuse and the legs. However, on the CXC formula sheet, instead of calling it hypotenuse squared is equal to LA squared plus LB squared, they will say C squared is equal to A squared plus B squared. The C is obviously the hypotenuse, and A and B are the represent the legs. I prefer to write formulas the way I will understand it better. Okay? Right? So, and also, and the reason I'm mentioning this is because I know some of you all will be accustomed with the C squared is equal to A squared plus B squared. So I thought it would have been a good idea to show you how the two are related. All right, so that's a question there. Let's take a next scene here. All right, so here we have another scene from Super Mario Brothers. So Mario is trying to jump to collect a coin or something like that. Let's move down. What are we trying to find here? In this question today, we're going to try to find the height from the top of the kind of incline all the way down to point B. So let's assume that Mario was standing on top here and he was to fall to the ground here. Let's try to find the distance he will fall. In other words, the distance what? A, B. So once again, this is what a gamer sees. And this is what a mathematician will see. All right, guys, I really apologize for how small the formulas are here, but I'll try my best to zoom in and zoom out. And of course, if you have a laptop, a really good idea, so watch this on your laptop. So we're going to assume that we have some measurements here. The first thing we have to do, well, you notice there's a kind of rectangle. It looks like a square to you all, from E to B to C to D, but most likely that's going to end up being a rectangle. What you need to know is that the opposite sides of a rectangle have the same length. So that means this length here from E to D will have the same length from B to C. Also, D to C will have the same length as from E to B. Here's the plan. We are going to try to find the distance BC first, and then we are going to try to find AB. So, and when we get both distances, when we get distance 1 and distance 2, we will add them to get the total distance from A to C. Right now, I know I made a mistake up here, right? I said B, but it's really supposed, it's not a big mistake. It's really supposed to be C. All right? The distance from A to C. Right, so what we're going to do, right? Let me erase the clutter here, right? I'm going to draw back this triangle here, EDC. Actually, I don't need to draw it back. Over here is going to be a right angle for sure. So let's pay attention to E, D, and C. What I am going to attempt to do is find the length of this side from E to D. Now, once I get the distance from E to D, I know it's going to be the same thing from here to here. I think I erased B by mistake. It's going to be the same distance from B to C. So let's identify. This side will be my hypotenuse because it is opposite the right angle. Here is the angle I am considering standing up in. So if I'm standing in the 40 degrees, then the question mark is my opposite. I could have written that better. That's not, guys. This side will be my opposite. and the 13 here will be my adjacent. So we have hypotenuse, opposite, and adjacent. Which one of these is useless? Well, it seems to me I want to find the opposite, and they gave me information on the adjacent. The hypotenuse is useless here. Because, once again, let me repeat, I'm starting in the 40. They want me to find the opposite, so that's super important. And they gave me information on the adjacent. So we're looking for a formula with O and A in it. Let's zoom in here. Which one has O and A in it? O and A seems to be tan, okay? So tan is what? Opposite over adjacent. And which one are they asking us to find? The opposite. So if they're asking us to find the opposite, we should block the opposite. So whatever we block, we write it. 1 second, guys. Whatever we want to find, we block it. So we block the opposite. So we put opposite and equal. So if we block the opposite, we end up with what? Adjacent multiplied by tan theta. I'm zooming in just to show you the multiply sign there, right? Right? Adjacent multiplied by tan theta. So you'll get adjacent multiplied by tan theta. So let's zoom out and see what values we have here again. We want to find the opposite side. So the adjacent is 13, if I'm not mistaken. Theta, so I'm accustomed to saying theta. It's just I could not have found the theta button when I was writing up the formulas. So theta is actually the angle, just like how A stands for the angle here. The angle we are standing up in is 40 degrees. So all we need to do is just type this in our calculator. Notice he is normal tan, not tan inverse. So let's type this in here. 13 multiplied by tan 40. And that will give me, well, if I round it off properly, I will get 10.91 meters. So the distance from B to C is 10.91. Right? You know why? Because if here's 10 point ED, we just found ED. ED is 10.91, and this length and this length is the same. So I just transferred over the value. Now we have to find AB. To find AB is going to be pretty easy. If from D to C, let me erase the clutter, right? If from D to C is 13 meters, the opposite side of the rectangle will also be 13. So here is also 13 meters. Remember, we're trying to find AB. We have the length of two sides. Look at this right angle triangle. A to E back to B. Here's the right angle. 22 is what? Your hypotenuse. Okay? So you have two sides and we're trying to find a missing side. This has nothing to do with an angle. Two sides and a missing side is who? Mr. Pythagoras Theorem. And 22 is the hypotenuse. So he will probably be leg A, and the 13 you could just probably call him leg B. So let's go ahead and do that. Let's find leg A. Hypotenuse squared is equal to leg A squared plus leg B squared. Hypotenuse is 22 squared. Leg A we don't know, and leg B is 13 squared. So how much is 22 squared? Now, instead of working out each one here, like 22 squared and writing it down, and 13 squared and writing it down, let's just throw it over one time. And we'll end up with 22 squared minus 13 squared is equal to LA squared, leg A. So we can work it out. It saves me a little bit of working. So 22 squared minus 13 squared, and we get 315. 315 is equal to LA squared. But we don't want leg A squared. We want LA, leg A alone. So we throw across the squared, and the opposite of squared is square root. So how much is the square root of 315? And we get how much? 17.75 if we round it off. So from A to B is 17.75. What's the total distance from A to C? The height that Mario falls. It will be 17.75 plus the 10.91. So 17.75 plus the 10.91 will give me a total of how much? 28.66 meters. All right, so that's the final answer. All right, now the truth is I had drawn other diagrams in case I needed other spaces to do some questions, but how I have these empty diagrams, I could probably use them to create some more. There's some more questions very, very quickly, right? All right, so let's change up some values here. Let's put some values and make a new question here. All right, so might as well use the space, right? All right, so let's say there's a quick making up a question. From B to A, let's assume it's 60 meters, and over here is 120 meters, and I want to find this angle here, right? Let's say I just want to find that angle. Let's make a quick question. We know here is the right angle, so the side opposite the right angle is the hypotenuse. The question is now, should we use one of the sine, tan, or cosine formulas, or should we use Pythagoras Theorem? Once again, there's an angle involved. We want to find an angle, so it's either going to be sine, tan, and cosine. For Pythagoras Theorem to work, we need two sides, and we have to be trying to find a missing side. Now we have two sides, but we are not trying to find a missing side. We are trying to find an angle. Once an angle is involved, it's either sine, tan, or cosine. So let's see which one it is quickly. Well, we just figured out here's the hypotenuse. If this is the angle we are trying to find, we have to pretend we're standing here. So this side is going to be my opposite, and the remaining side is the adjacent. So it seems to me we've been given information on the adjacent and the hypotenuse. We have the 60 and 120. The opposite, we have no information on it, nor do they want us to find it. So he is useless. So which one has adjacent and hypotenuse in it? Adjacent and hypotenuse. See if you can remember. To me, adjacent and hypotenuse is the cosine. And remember, this angle here, the A, that's the angle we are trying to find. Okay? So if we're trying to find the angle A, right? If we're trying to find the angle, then we have to block the cos A. Once again, anytime you're trying to find the angle, you're either blocking the sine, tan, or cosine. Since we're using the cosine formula, we're going to block the cosine. So block cos A, whatever you block, you write it. Now, sometimes instead of calling it cos A, I just call it cos theta. Whatever you put after sine, tan, or cos, right after represents the angle. So if I block cos A, I am left with adjacent divided by hypotenuse. The adjacent is how much? 60, and the hypotenuse is 120. 60 divided by 120 is 0.5. So cos A is 0.5. I guess that's the end of the question. No, that's not the end of the question. Whenever you're trying to find an angle, you will always have this one last annoying step to do. You will either have to throw across the sine, tan, or cosine in this case here, to get cos inverse. Only after we cos inverse and leave the angle alone on this side, then we are finished. Cos inverse 0.5 is 60 degrees. So the angle is 60 degrees. All right, let's go down here. All right, so I'm just going to leave this one blank, right, and move on to the next one here. Here's another scene from Mario Brothers, okay? Let's see what the mathematician will see when he's playing this game. This is what he sees instead. All right, so I did the diagram about 3 times, so that means I'm going to try to find 3 things here. All right. What we're going to be doing, this here is something I wanted to prove to some students. Here's what I want to do. I want to find BE first. So let me change the color here. Let's say I want to find BE. B all the way to E. You notice I've been given 2 sides and they want me to find a missing side. So that's Pythagoras Theorem. I know I'm repeating myself, but I want it to stick in your head. Like when you finish this tutorial, I want you to memorize everything, or all the important details at least. Pythagoras Theorem is used when you're given 2 sides of a right angle triangle and they want you to find the missing side. This is a perfect opportunity. Here's the right angle. The side opposite the right angle is your hypotenuse. The other 2 sides are just leg A and leg B. So hypotenuse squared is equal to leg A squared plus leg B squared. Hypotenuse is 20, so it's 20 squared. Leg A, we do not know. Leg B is how much? 11. And of course, we have to square it according to the formula. Let's not work it out now. Let's throw it across first. So we end up with 20 squared minus 11 squared is equal to leg A squared. So we're going to work out the left-hand side and then square root our answer. 20 squared minus 11 squared will give us 279. Oops. Is equal to LA squared. Throw across the squared to finally get a square root. Now, make sure and stay for the next part of this question. It's going to be, you might think the next part is just going to be a repeat, but the next part is going to be really important. So, square root of 279. Okay, and I'm going to get 16.7. Right, so let me just double check that, because if this is wrong, the next part of the question will also be wrong. Right, and square root. Yep, it's correct. So that means from B to E, right, is 16.7. So I'm going to transfer this downstairs here, right, 16.7. So, oh, I didn't write it in just now. 20, 11, and 16 point. 20, 11, and 16.7. That's one, guys. 20 meters. Here's 16.7. And the other one was how much? 11. Now, notice we have the length of all 3 sides of the right angle triangle. Let's choose an angle to find. I'm just going to choose this one here. Let's say we want to find this angle. Usually, when we want to find an angle, we only have the length of 2 sides. We might have opposite and hypotenuse, or opposite and adjacent. Whenever you have 2 sides, you have to choose one, either sine, tan, or cosine, all depending on which sides you are given. So when you're given the length of only 2 sides, you are limited to using only one of the formulas. However, whenever you have all 3 sides of the triangle and they want you to find a missing side, then you have the luxury of choosing any one of the formulas. Now, whenever I tell students that, they get happy, but then they do the wrong thing after. They think they can choose any one of the formulas and throw in any one of the two sides into the formula. It doesn't work like that. So that's why I'm going to take my time. So I have all three sides of the triangle, and let's say I decided to use tan now, because when you have all three sides, you have the luxury of using any one. If we're using sine, then sine, but the angle is A. Remember, what is, I don't like calling it A, and let's just call it theta. So if I'm trying to find the angle, I have to block off the sine. So if I block off the sine, I am left with opposite divided by hypotenuse. Remember, if this is the right angle, here's the opposite. Let me get different. Right? Here's the opposite. The side opposite the right angle is the opposite. If this is the angle we are trying to find, then over here, sorry, I made a mistake. I'm talking. All right. Sorry about that, guys. The side opposite the right angle is the hypotenuse. Correct now. If this is the angle we're standing up in, then the 16.7 is the opposite, making the 11 the adjacent. So you understand that, right? Remember, I always find hypotenuse first, then the opposite, and then the adjacent. So if we decide to use sine, we have to take opposite and divide it by hypotenuse. The opposite is 16.7. The hypotenuse is 20. So what we have to do is divide these two and then sine inverse the answer to get the angle. So let's try this. 16.7 divided by 20. I'm just going to go to use all the decimal with 0.835. So that means sine theta is equal to 0.835. To find the angle, we throw across sine to get what? Sine inverse of 0.835. Let's sine inverse this. Second function, sine 0.835. And the angle we get is 56.61 degrees. Right? Let's call it that. So let's take a note of the answer here. The answer that we got up here was 56.61 degrees. Let's try one of the other. Let's try tan now. So right, we get the eraser here. Right. Let's try tan now. Right. If we're going to use tan, right, we have to block tan theta. Tan theta. So whatever we block, we write it. So if we block tan theta, we are left instead with opposite over adjacent. Remember, with sine, we were left with opposite over hypotenuse. So now we're left with opposite over adjacent. So the opposite side is 16.7 and the adjacent side is actually 11. So let's divide that. 16.7 divided by 11, and we get roughly, I just go into plenty decimal, 1.518. I just want to prove a point, right? When we get this, we have to tan inverse the answer. So to get the angle, we throw across the tan, and it's tan inverse 1.518. So let's try that. Second function, tan 1.518, and we get roughly the same answer. Look at it, 56 point something. The only reason we're getting slightly different answers because I'm rounding off a little bit. So what happens now if we use how you call this guy, tan now, right? I know why the eraser isn't working, right? Sorry about that. Can't figure out what's going on. Alright, so it's eraser now. let's use the last one on the list there, right? Let's use the cosine. So if we're using the cosine, let's block the cos. So you get cos theta. Whatever we block, we write it. So if we scratch him off there, we're left with adjacent over hypotenuse. See, it's a different combination of letters in each case. So the adjacent side now is 11 and the hypotenuse is 20. So 11 divided by 20 is 0.55. And I know by now, you know that's not the end. You have to throw across the cos. And you get cos inverse 0.55. So second function cosine 0.55. And we get roughly the same answer, 56.63. So 56.6. The moral of the story is, whenever you have the length of all three sides of a right angle triangle and you want to find a particular angle, you can use either sine, tan, or cosine, but be very careful. If it's sine, you have to use opposite and hypotenuse. If it's tan, it's opposite and adjacent. If it's cosine, it's adjacent and hypotenuse. So guys, I really hope this tutorial was a good refresher. This is something I would recommend like just before you write one of your exams. It's a good revision tool, right? You know, I didn't start from basics. I took like a midway point, right? So this is more of a revision tutorial. And I hoped that the Mario Brother concept made it a little more tolerable, a little more fun, and you didn't fall asleep watching the video. So guys, thank you for watching, and of course, if you like it, leave comments, right? If you like this series of videos and it's actually helping you retain the material better, let me know, and I'll probably consider doing more tutorials involving games or something you're like movies. Or I'll try. I have to think about it. All right, guys. So I really had fun making this video. I really did. All right. Take care, guys, and well, see you soon.